Kia ora whānau. This is one of many videos you'll find on the Maths OSC YouTube channel on the New Zealand Statistics curriculum. This video is about probability trees, or in short, a visual way of representing basic probabilities. Today we're going to be talking about sampling with replacement. In simple terms, that just means that each event is equally likely. Now we'll see this with a bit more clarity in the example that follows, but this video assumes that you know what probability is, or you know a bit about basic probability. If your knowledge in that area is a bit sketchy, maybe you'd like to find out before you watch this video. Anyway, let's get straight into it with an example. So here's the question. A family decides to have 2 children. The chance of conceiving a girl is 60%. So let's firstly set up the tree. Now remember, we're going to have 2 children in the family, so we need to set up the tree to cater for that. So there's my first branch. Oh, I went a bit too far there. There's my first branch, and that represents the first child. But I also need to represent the second child. And that's the second branch. So let's begin filling in the gaps. Now, what I'm pointing to there is the 60%. Now, translated into a proportion or a decimal, 60% is 0.6. So there's a 0.6 chance, or a probability of 0.6, that we're going to have a girl, or the family's going to have a girl. But remember, there's not just a girl that they could also have a boy. And what is the chance of a boy being born? Well, if we subtract 60% from 100%, we're left with 40%. And that will be represented by 0.4. Now if you notice, when you add up the 0.6 and the 0.4, it should add to 1. Now this is a check for you, so at this stage when you're drawing the tree, you should make sure that what you've put there adds to 1. If it becomes, or if the numbers on your tree are more than 1 or less than 1, you know you've done something wrong. So let's begin to fill in the rest of the tree. So that's the first baby there. That's the branch on the far left. And remember, we're looking at the second set of branches, which is going to represent the second baby. So let's begin to fill in the rest of the gaps. And there you have it, a complete probability tree. Notice that as we go from the first baby to the second baby, the probabilities stay the same. That's because we are assuming that each event is equally likely to occur, or we are sampling with replacement. So in terms of the total outcomes of this tree, okay, we have GG, which is the 2 girls. So it's possible that the family could have 2 girls. Or it's also possible that the family could have 1 girl and 1 boy. So the girl first and then the boy second. But we could also have that combination the other way around. So the boy child could come first and then the girl child could come second. Or there may not be any girls in the family at all. And in that case, we're going to have 2 boys. So now let's actually look further into this. I'm going to ask you guys a question. What is the probability of the family having just 2 girls? Well, let's check this out. 2 girls. Now let's find 2 girls under the outcomes list. So let's look at the outcomes, and there we go. There we have the 2 girls. And if we look on a probability tree, that is the part of the tree that concerns us. So in terms of calculating the probability, okay, now this becomes reasonably straightforward. So let's document the answer now. And you should be able to see this pretty clearly. So there's our 2 girls, and we generally note probability like that. So that just means the probability of 2 girls, and then equals 0.6 times 0.6. So that's the 2 0.6s from along that probability tree, the first baby and the second baby. Because we want 2 girls together, we're going to multiply those 2 probabilities, and we end up getting an answer of 0.36. So that is the probability of the family having 2 girls. Let's ask one more question. What is the probability of having a baby boy second? Well, let's again look at what we've got in our tree here. So remember, we're looking for a baby boy second, not first, second. Let's look at our outcomes list, and there we go. There's one combination of babies where the boy is born second. But remember, we also have another combination where the boy is born second. So it doesn't matter about who the first child is or what gender the first child is. It's more important here that the boy is second. So let's use this information to calculate the probability that we need. So those are our 2 areas of our branches that we're going to be concerned with. So it's a good idea to that's why it's a good idea to draw out a tree so you can see what's going on. And there we go, there are our outcomes, and we're going to note them using our probability notation. So the probability of GB and the probability of BB. Now we're going to use the probabilities that we found, 0.6 times 0.4. We're going to multiply them together to get 0.24. 0.4 times 0.4 equals 0.16. But this time we are going to add the 2 numbers that we found together to get the total probability. So the chance of having a boy second for this family is going to be 0.4. Now just remember, once you have your probability tree and you've got your outcomes listed, okay, it should become reasonably straightforward for you to calculate probabilities. Thank you for watching. I hope you can tune in next time for more statistics. Tune into Maths OSC for more statistics and more calculus videos. Thank you very much.